Hey guys, I'm Shreya and I am happy to work as an intern under the Sparks Foundation in the data science and business analytics. So, I am sharing my experience. The first task is the prediction using supervised ML. Supervised ML is basically when we have the input data and the output data and we map them using an algorithm. So the problem statement which was given to us is predict the percentage of the student based on a number of hours. What will be the predicted score if a student studies for 9.25 hours per day? The data given to us was this, um, so which depict the scores and the hours. Yeah. So the first step is importing the libraries. So we will be importing the necessary libraries. And the second step, we load the given file. So this is the step to load the given file, and the name of my data set is the file underscore data. To see the loaded file, we give the command file underscore data dot head, and here I have specified 15. You can specify any number, but that depends how many rows you have. So the next step is just to check what is the shape of our file data. So it depicts 25 comma 2, which means 25 rows and 2 columns. This is the further descriptions of the file data, and this is the further information which tells how many entries are there and also what is the data type. Now come to the plotting the distribution of the schools. So I have tried plotting various graphs. So the first is the scatter plot. So this is this plot, and where it's since it is a linear regression, so we get a straight line and all data points are near that. Similarly, this is another type of graph. So this is how we're getting a line, and we can specify the marker over here. So we can specify any style you want. This is the array of the file data. And the next I tried the bar plot. I have tried different two types of bar plot. This is the normal one and the other is the stacked one. And we can see it clearly shows hours and the scores. Hours are the blue markings and the scores are the orange one. And since it's basically linear, so it's kind of like if a person studies for zero point 0.5 hours, so he or she is getting the score 21. So this is the linear relationship. And another, I have tried the horizontal bar plot. Again, the normal and the stacked one. And this is the another I have tried. This really shows the more uh, proper data, like 2.5, 5.1, number of hours studied, and the percentage score. Um, Next, I tried the box plot, um, which I found is kind of weird because of this structure, but it's interesting. And then I checked the file data. So this clearly depicts all the 25 rows and 2 columns. Next, this is the box plot for the scores, and this is for the hours. And I've also tried the volume plot. Now we come for preparing the data. We're dividing our data into attributes and label. So this is the way, and X it depicts all the hours and Y it depicts all the scores. Next we go for training the algorithm. We split the file into testing and training sets. Um, so this is the step, and over here I have specified test size 0.3, that is 30% of my data will be going into the testing and the rest 70% to the training. And this is how I am creating the regression line, and this is the graph I got. So all the data points are near this line. Now the next step is the making prediction. So this is the based on the test size we are getting X test these specific numbers, and the y predicted. Then this is the array, and then we are comparing the actual versus predicted values. So this is, we can see the change, and we are testing our own model. So based on this test, we get the predicted score for this student who studies 9.25 hours is 92.9, and the accuracy of the model is 4 point, like this is the absolute error is 4.41. The one another thing is, if I change this to, let's say, zero point 0.5, so we can see the small change. uh yeah, so over here the more data is there. Similarly, you can see the more data into the y, and yeah, based on the our testing size, and we can see how much uh, comparison is there. And then when we predict this, we can see the percentage score 91.7, or it was 92 point something. On the accuracy, I mean the absolute error is 5.71. If I change this to 0.7, there will be more changes, like it will decrease more. But since we don't have too much big data to this isn't making a much difference. So so thank you guys for listening to me, and I would like to get the feedback from you all. Thank you.